So next is super heterodyne receiver. Before that, one more parameter is there, fidelity. It is the ability of the receiver to reproduce all the audio frequency at the output. So for example, in AM, 20 Hz to 20 kHz is the audio frequency. Then the system should reproduce all the audio frequency at the output, but it is not actually possible. Why? Because bandwidth is limited to 10 kHz in AM. So 20 Hz to 20 kHz, the entire frequencies won't reflect at the output. So the problem is, by using in AM the fidelity is very less, but in FM we can increase the fidelity. So next is super heterodyne receiver. This is another receiver. So here the it is quite different from the tuned radio frequency receiver. The difference is, here we introduce another block, intermediate frequency. So the incoming signal is the received frequency Fs. First stage is RF amplifier, next stage is mixer, next stage IF amplifier, demodulator, AF amplifier, power amplifier, loudspeaker. So mixer is given to a local oscillator with a frequency of FL. So incoming frequency is Fs. So the antenna receiving the incoming frequency, antenna receives the radio frequencies, and it is given to the RF amplifier. You know what the first stage is, normally RF amplifier, a tuned RF amplifier to increase the incoming signal frequency, and to select the particular band of frequency we use a tuned RF amplifier here. So output is RF only. So next is a mixer stage. The mixer stage down convert the incoming signal, RF signal, into intermediate frequency. Okay. So FL is the local oscillator frequency, and this local oscillator frequency is compared with the signal frequency, and the difference we take it as outside, and that difference frequency is called the intermediate frequency, and normally it is a constant, and that intermediate frequency is amplified with this IF amplifier. Then as usual, demodulate the IF to AF amplifier, then power amplifier, loudspeaker. So the thing is, IF, for example, I am taking intermediate frequency for AM, normally it is fixed as 455 kHz. So the incoming signal frequency, for example, Fs is 1000 kHz. So I am keeping, so incoming signal is 1000. So I should keep this FL as 1455 kHz, then only I will be able to get to 455. So what is the output here? Difference between these two frequencies is the output at the mixer. So this output mixer frequency is called intermediate frequency. What is that? IF is equal to FL minus Fs. Which one is higher? That is subtracted from the lower. Lower frequency subtracted from the higher frequency. That is FL minus Fs. That is 455 kHz. So 455 kHz we will get at here, and that 455 kHz is amplified with this IF amplifier, then demodulator, follows amplifier and power amplifier. So here also bandwidth we keep it as 10 kHz, and quality factor, just divide these two, will get a Q is equal to 445.5. This is a super heterodyne receiver. Okay, so the next is image frequency and its rejection. Look at here. In this super heterodyne receiver, so the first stage, I am keeping Fs incoming signal frequency as 1000 kHz. Okay, local oscillator frequency I am keeping it as 1455 kHz. So definitely the difference between these two is given at output of mixer, that is 455 kHz. So I am keeping this as 1455 kHz, and incoming is 1000 kHz. Now consider another case. I am keeping FL as 1455, 1455 kHz. I am keeping that. It is, suppose in this situation, another frequency, that means the antenna is receiving all the signal from the air free space. Suppose there is an adjacent station here, that frequency also comes into here, and this antenna definitely receives all the frequency. And suppose that incoming frequency is 1910 kHz. So here 1000 km, first case 1000 km, it is down converted to 455. At the same time, another frequency 1910 kHz came. What will happen? Local oscillator is 1455, incoming frequency 1910 kilohertz. So what is the difference? Again the same frequency 455 kilohertz. My system I designed to receive 1000 kilohertz. System definitely will receive the 1000 kilohertz, but at the same time another station frequency 1910 came. At the same time also the system receives this frequency and it is downconverted to 455 kilohertz. So what is the problem? What I am expecting is 1000 kilohertz. My signal frequency is at 1000 kilohertz, but what I get 1910 kilohertz. I am expecting this frequency only. I need only this frequency and it should be converted into 455. Why? Because I am transmitting my information at this frequency, but my friend is transmitting his information at another frequency 1910, and that frequency also received by this receiver, and it is downconverted into 455 kilohertz. For as far as my concern, this is a noise to me. Okay. Why? Because my information is in 1000 kilohertz and that is downconverted to 455. Then it is okay. But consider this case, incoming frequency is 1910. So the frequency is different, but the information is same here. The same here. My information is this frequency. This is my friend's information. Okay, for example, say. So this is downconverted to 455 kilohertz. By looking, you may see that both the frequencies are same, but information is different in these two frequency. Clear? So this should be eliminated. This is the unwanted frequency. So this frequency is called image frequency. So I am designing a system for a particular frequency. The same system itself receiving another frequency from an adjacent station, and that frequency also downconverted into same IF. So this creates a problem. So my information is get lost or get interfered with this noise. As far as my concern, this is noise, no. So that is interfered with my system, and definitely this should be eliminated. And this frequency is called image frequency. Okay. So the equation for image frequency FSI equal to Fs plus 2 times IF. So for example, FSI is the image frequency. So incoming signal frequency is 1000 kilohertz. How to find out? This is my system. Okay. Anyway, I need to eliminate this. So this is my system frequency. My signal frequency is 1000 kilohertz. So I should be able to get what is my image frequency. Okay. So I am taking 1000 here and 2 times IF. What is IF? 455. 2 times IF plus 1000. You will add. You will get this frequency. So I am expecting that I may get a image frequency, and that frequency can be 1910. I am calculating with this equation. I can predict that frequency. So this is my image frequency. Now I know that when this frequency came, definitely it will be, my system will be down convert that frequency to IF, and it will be a noise for my system. So I should eliminate this frequency. So I am predicting that image frequency, and that frequency should be eliminated. How this frequency is eliminated? This frequency can be eliminated with the help of a tuned circuit at the input of the mixer. So simply you put a tuned circuit at input of the mixer, you can eliminate this image frequency. How? This diagram will tell how that image frequency rejection will happen. Suppose this is the I told that I am keeping a tuned circuit at the input of the mixer. So that tuned circuit have a frequency response like this. See, this system, that tuned circuit provide a maximum gain for my frequency only. For example, Fs I am taking, my signal frequency is 1000. For 1000 I am giving, for 1000 that tuned circuit will give a maximum gain. So for FSI is what here? 1910. For FSI I am keeping that tuned circuit in such a way that for FSI it should give a gain of 0.01. Okay, that means gain is very less for this signal frequency. So what will happen when 1910 frequency, that means my image frequency came into the system. What happens when the image frequency comes into the system, the tuned circuit at this mixer will produce or will attenuate that signal. That means the gain is very less, so signal will naturally getting reduced. So the amplitude of the signal is very feeble, so it won't get affect my signal. Why? Because the gain is very less now. So my signal gain, my signal incoming signal frequency, my tuned circuit will give a maximum gain of 1. For the image frequency, I can predict this image frequency with the equation fsi equal to fs plus 2 times if, and that frequency I am keeping here with a very less gain, so that whenever that frequency enters into the system, definitely it will be eliminated with this. Okay, this is the image frequency rejection.